Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and apparently electronics and Nintendo Switches. What's up with that? Alright, here we go. We are back on my second Switch. This is part two. I have discovered some issues, so we're going to take a look at what we have here. Okay, so this was fully tested and it doesn't dock. So it charges, the USB port seems to be a little bit off, but it works, it charges, all the pins seem to make contact. So the issue is here, and I'll show you this if we can get everything to cooperate. And let's focus this on this side of the board. Okay, right there we have PS113 USB. So, and we have our little meter going on there. I guess I can put that in the corner down. Well, let's put it in here out of the way. So, right now we're doing voltage. We don't want to do voltage. We want to do continuity mode. But before I show you that, let me show you this. On this monitor here, I have a spreadsheet of PS 113, and I need to check these pins down here because this is the diode reading. I'm looking for 0.743 on these first two pins in the bottom left-hand corner, as the letters are written on the chip. So I want to show you. I'll show you what I'm looking for here. It's these two pins right here. Is it these two? Yeah, it's these two pins. Yeah, because pin 1 is over here. It's these two pins right here I need to check in diode mode, and I'll show you what I discovered with this. So let me get my meter here into diode mode. And then I'm going to put a red probe on ground with my little clip to the USB port. And I'm going to take my black probe and I'm going to try to touch this pin right here. I get 743, which I'm supposed to get. If I touch this pin, it's open line. That's supposed to be 743, not 0.743. And if I come over here and I then check this filter, I'll put this in continuity mode now. If I check in continuity mode, if it changes, if I check this filter here, see, this is not going to work on here. So what I'm going to do is I'm going to show you how I'm going to test this filter, and I'm going to show you that it's bad. Let me take off the big camera and let's go this way. Let's put that one on. I decided to shut down, and I'm going to get my LCR meter, my little tweezers, because it makes it easier to grab onto this, and then you can see what it says. So I'm going to take this here and I'm going to put it in inductor mode, so L, inductor mode. I'm going to try to get this all on camera, working with a pair of tweezers. And so if I come in here and I touch, I got 125 nanohenries going up. Okay, that's that side of the filter. If I touch the other side of the filter, I'm touching, hold on, there's the alarm. So if I touch this side of the filter here, you get about 100 nanohenries. If I come over here and I touch one of these filters, which they're all the same, it's 0. So that filter is bad. Is it bad on both sides? No, just the one side is bad. So when I first tested it, I thought it was fine because, you know, it's supposed to be an inductor, but subsequent tests of these inductors show that they're 0 inductance. So what I thought might have been the chip, I believe it's this filter right here. So we're going to be changing that later on here, and I don't think I'm going to change this USB port. It doesn't look too bad. I don't want to mess it up more, but I do want this to be a working switch for testing purposes. So that's where we're all on this. I'm going to come back and we are going to change this EMI filter on this board. Thanks. Okay guys, I'm back and with this switch here, and I already changed the EMI filter. I have a completely new microscope set up video on the channel. I changed this EMI filter on a stream to test out my new Quick 861 DW hot air station. So far I have mixed feelings about it. I'm still trying to figure out the settings. I just opened it today at the filming of this. I changed that EMI filter, but I ran into another issue. It still wouldn't dock. Let me put that up there. There you go. I changed that EMI filter with the Quick Station. It went pretty easy. I did it on a live stream. But if I come in here and I show you this pin right here on P13, that track is loose. So P13 is either blown or that track is wrecked. So this is going to need trace repair. I have a little bit of wire right here that I'm going to run from this point down to this point down here on this filter. I'm going to run it from here to there after I change P13 and see what kind of damage there is to the pads. I don't know. I don't think this one is messed up. That one feels solid, but this one is definitely loose. So I'm going to have to address that. I'm probably honestly going to do the trace repair on a live stream, but I will go over what I did in the next of these videos. I'm going to call it on this one. I want to get this video out there explaining what I have left to do, and be on the lookout for the live stream where I changed this EMI filter and where I'm going to do this this trace repair. This may come out before I even do the trace repair on a live stream because I am waiting for some stuff, and I have taken a week off for the holidays because it's around Thanksgiving here for us. So I'm taking that week off. So this will come out after that, but I'm going to be doing that trace repair, and then I will come back and do a follow-up video on this and it working, and that should be a completed fit switch that completely works, and I will keep it as a known good switch for testing different things. So that's going to do it for this video, guys. Links to social media as always, and a link to my Patreon page. I have now posted a Excel spreadsheet to show you all my different data points. There's no need to sign up. You can go there and download the file for free, and you can check out all the information I have. It's my parts list and also all the diode pin mode readings for the 3 main chips, and I'm going to be filling that in with other stuff in the future. Thank you so much and have a fantastic day.